current I in the below network is option A 0 ampere, option D 2.38 angle minus 96.37 degrees, option C 2.38 angle 143.63 degrees, option D 2.38 angle minus 23.63 degrees. For a detailed video on the basic concepts, please refer the NPTEL Lecture 5 Basic Electrical Technology, Dr. L. Umananth, Power Electronics Group, IISc, Bangalore. In order to solve this problem, we need to know the concept of Kirchhoff's current law and the rectangular form to polar form conversion method. The Kirchhoff's current law states that the algebraic sum of all the currents entering and exiting a node is equal to 0. In the node shown in the figure, we have 2 currents that are entering and 3 currents that are leaving. According to the Kirchhoff's current law, I1 plus I2 is equal to I3 plus I4 plus I5. The rectangular form is the complex form and the polar form is the r theta form. To convert from rectangular form to polar form, the magnitude of the polar form can be calculated by the square root of real part square plus the imaginary part square. The angle of the polar form will be tan inverse of imaginary part divided by the real part. To convert from polar form to rectangular form, we need to find out the real part and the imaginary part. The real part is r cos theta. This is magnitude times cos theta. The imaginary part is r sin theta or magnitude times sin theta. Assume that this current is IA and then this current is IB. Here, all the 3 currents are entering this node. Therefore, according to the Kirchhoff's current law, I will be minus IA minus IB. This will be IA is voltage divided by the impedance Z. IB is this voltage divided by this impedance Z, which is this is the value of IA and this is the value of IB. For doing the division, we need to convert the rectangular form into polar form. 80 minus j 35 is the value of the impedance. The magnitude of the impedance will be the square root of 80 square plus 35 square. This will be 87.32. The angle will be the tan inverse of minus 35 by 80. This angle will be minus 23.605 degrees. So therefore, 80 minus 35 can be said as 87.32 angle minus 23.605. Implies that I equals minus of 120 angle minus 90 degree divided by 87.32 angle minus 23.605 degrees minus of 120, this is 120 angle minus 30 degree divided by 87.32 angle minus 23.605. While dividing, we will be dividing the magnitudes and adding the angles algebraically. Minus 6.395 degrees. So we need to do the addition operation of these two things. So which implies that I will be minus of this term in rectangular form plus this term in rectangular form, which will be 1.374 cos minus 66.39. This is 0.55 plus j 1.374 sin minus 66.39. This is j 1.258, and we need to convert this also into rectangular form, which is 1.374 cos minus 6.395, which is 1.365 plus j minus 0.153. We can now add the real part separately and the imaginary part separately. So I will be 1.365 minus 0.55, which is, this will be minus 1.915 minus 1.411. So this is minus 1.195 plus 1.411. We need to convert it into polar form because we have the options here in polar form. Therefore, the value of I will be square root of 1.915 square plus 1.411 square. The angle will be tan inverse 1.411 divided by minus 1.915. This is 2.38 angle. This is close to 143.63 degrees. So this is our answer. The answer is option C, 2.38 angle 143.63 degrees ampere.